Did who? He took a break. He made it kind of, he wanted to leave really early. I was like, no. I'll send over the paper.
Joyce, did you get credit?
You good? Okay. You can answer. Come on in. Come on in, come on in. Oh, you mean your math book?
Yeah.
Oh. I can get it. Oh, you forgot it at home?
Yeah.
Okay. It'll cost you a walking ticket, but there should be... There you go.
I think someone...
Should be okay. I don't think anyone used it today, but you can check. Just one up. Zach, what are you supposed to be doing right now, sir? Okay, I think it's 52. Do I need to start it? Do I need to start it, Mandy? So you got both of those right. Nice job, Lily. 53. Yep. So one of those is right, the other two are incorrect, Zach. So when we go over them, I want you to watch really carefully, okay? Okay, get your journal set up. Are you guys squished back here? Do you want some room?
I'm fine.
You okay? Hey, Jonathan, you got both of those right. Good job, dude. So did Anna. Nice job. So you don't have yours. We're going to go over it, so you'll have it done. Page 53. You didn't get done. How come? How come?
I just didn't.
Ooh, try again.
I did.
You just didn't do it. Okay, did you forget your book at school? Did you not make time? Did you forget to check the planner?
I forgot to check my planner, so
Sorry.
I used it.
Okay, so what are you going to do tonight differently?
I'm going to check my planner.
Okay, did you write in your planner?
Yeah.
No, we didn't even write it in our planners yesterday because we were rushed, so we just circled it.
Oh.
That's why. Same with you, Robert. What happened with yours?
I forgot to do it.
You just forgot. Okay. Excuse me? One of those is correct, Bradley. The other is not. So watch when we go over it, okay?
I got kind of confused here.
That one's correct. There's one that you missed, Kate. So we'll go over it, okay? Page 53. You get that lucky seat right next to the camera, my dear. One of those is incorrect. Actually, two of them are incorrect. So when we go over them, I want to show you which one's okay.
Yep.
Page 53. Okay, this one was the homework 11. Just forgot. Okay. No more just forgetting. That's 2 days in a row. Okay. Good job. One of those is correct, or two of those are correct, one of them is incorrect. So watch when we go over them, okay? Good job getting that done. Osvaldo, help me understand. You were supposed to select all the statements that were true. So which ones are true? Did you mark them weird? That one was true. Okay, I'll let you go through and fix that. One of those is incorrect, Joyce, so when we go over it, watch what we do, okay? Manual, one of those is incorrect and one of them's correct, so when we go over them today, watch carefully, okay? Quick. Is your journal set up? One of those is correct, Lisbeth, the others are not, okay? Where is your name? There you go. Two of them are correct, one of them's not, okay? So when we go over those, I want to show you which ones, okay? One of those is correct, Javen, the other one's not, okay? So when we go over those, I want you to watch really carefully. Same with you. One of those is not correct, Minraj. Tanner, you were absent yesterday, right? It's 53. Yep, you got them both correct. Nice job, dude. Give you about 30 more seconds to make sure your journal looks fantastic. I didn't see your... Sorry. Nice job. Did Brayden leave? Do you guys know where Brayden went? To the nurse. Good morning, mathematicians. Good morning, Mrs. Lofa. All right, let's just check in, make sure our journals are looking up to par. Can you give me a thumbs up if you have the standard written down in your journal? Standard not written down yet? You don't have your math journal again today? Where do you think you saw it last? It's not in your backpack? Okay, your goal by the end of the day is to find that math journal. It couldn't have disappeared. Thumbs up if you have the learning target written down. Tanner, are you getting that written down right now? Jonathan's getting it written down. Okay, let's read it together so we know what we're working on today. Ready, set, begin. I can use and draw a histogram to describe data distribution. So we are going to be working on histograms today. We're going to be drawing histograms today. We're going to be talking about histograms today. It's really just kind of a continuation of yesterday. Shouldn't be too hard, okay? Thumbs up if you have your table of contents done. Osvaldo, you should be doing that right now then. Looks like just about everybody else has it done. Yep, okay, cool, awesome. Well, good morning to you. I'd like you to flip back to yesterday's lesson so you can refresh your brain on what we learned. So find lesson 6 in your journals and in your books, I suppose. Lesson 6. Okay, everyone on lesson 6? Okay, I'm going to give you 2 minutes. What are you going to do during that time? You're going to add to your notes. You're going to read through the summary. You're going to read what you wrote yesterday, and you're probably going to need to write your summary, okay? All of that in 2 minutes. Ready, go. Hmm. I would just call them the histogram bars, maybe. Mm-hmm. Would you take a moment and tell your neighbor what you learned in lesson 6? Go ahead.
How to use histograms and how histograms work in different situations better than dot plots. How to plot stuff like it's kind of like histogram is that value it's playing in groups of things every center size.
Can you save these for lunch since that's not a super healthy snack? Thank you.
The way the bar tell you the of what is that. Is that staring at me?
So that's like the third definition of histogram.
Could you put that in your own words? Do you understand it well enough?
Yeah, I do. That,
Okay.
I explained before that, but I just wanted to say that.
You wanted to read the actual definition? I wouldn't even touch it. Yeah, because Miss Kraft's dealing with it. If you can hear my voice, clap once. Awesome. Joyce, can you add an activity minute? Well done. Thank you, Hunter, for remembering. Heard a lot of great sharing. I'm going to hear three of your thoughts. And Joyce, get ready to add some team points as well. Purple number 1. Is that Kennedy? Okay, ma'am. What's one thing you learned yesterday? Okay, how do they work?
They're not always like
Okay, what do you mean by that? It is hard to explain. Talk to me about the bottom data. How is it like maybe different than a bar graph that we talked about?
I don't know.
There's something weird about the bottom. Can someone help Kennedy out? What is interesting about the bottom data of a histogram? Yeah, remember.
it has like it's a range of numbers, so it's like 0 to like
Right. It's a range of numbers. So instead of it just being one number, it's what? It's a range of numbers. Okay, awesome. You can have 5 points for purple team. Orange team, number 1. What did you learn yesterday? Huh? Put that in your own words.
What I learned yesterday was how to use histograms to align data in
Perfect. And was there a time when histograms were a little bit more helpful than dot plots yesterday? Yeah, and why was that? Or what the dot plot showed? And why it was kind of hard to see it? Hey, Wayne. Look at the dot plot from yesterday, and I'll come back to you. There was something specific about that dot plot that a histogram was way easier to use. Green team, number 1. Robert, is that you? Okay. What did you learn yesterday?
I learned that histograms are an easy way to show the data.
Okay, an easy way to show the data. When is it easier to use a histogram than maybe a dot plot? Emmanuel's kind of searching for this answer too. Do you remember that dot plot we used yesterday? What was kind of weird about it?
It was all clumped together.
It was all clumped together. So it made it hard to do what?
To show the data.
Exactly. We couldn't really interpret the data at all. So a histogram was easier because the data was really what?
Shown in a small space.
It was shown in a small space. So using a histogram made it more clear to see, I guess is the best way to say it. Okay, got it. Awesome. Emmanuel, do you kind of agree with what Robert was saying? Is there anybody that wanted to share anything different besides what's already been shared? Okay, Joyce, can you add 3 points for orange and 5 points for green? Did you want to share something? Go for it. Right, kind of like what Joyce was saying, you can do a range of numbers. Yeah, totally. Okay, awesome. Let's go ahead and go over last night's homework. So I believe it's page 53. Okay, page 53, and I have to apologize. We ran out of time to write this in our planner because it was just kind of at the end of the day, so I just had you circle it. Hopefully that was enough for you to remember that you had homework. We're kind of getting to the point where you need to be responsible to know if you have homework or not. Welcome to almost junior high. Okay, could I have a volunteer to read number 2 out loud, nice and loud? Carlos L., go for it, dude.
Here is a histogram that summarizes the lengths and feet of a group of adult female sharks. Select all the statements that are true according to the histogram.
Okay, so those of you who were gone, if you could definitely do this, but everybody, will you compare your answers with your teammates' heads together?
So what I got was B and D because I counted.
Oh, I would like to see it.
Of the number of
You got it.
sharks that
Great,
are,
good job.
and I got 15.
I got my book,
That's okay.
but I'm pretty sure I got B. I got B, and I think I got C.
Did you finish?
Yeah, and I got E because
Well, no,
there were
not
two
D.
that were measured less than 14 feet.
Yeah, so I'm gonna go with D.
Yeah. I was thinking a little bit like there had to be another answer, but then I thought about it and there was like, I didn't really think any other answer could be correct.
Sure, what you mean.
But I really like using histograms better than dot plots.
About 30 seconds left.
It shows more data.
You guys should all be in agreement.
Yeah, I wish it had less of a range of numbers on the bottom.
Yeah.
On some of them, but that's okay.
Me too.
It's
It gets
yeah,
but pretty neat.
yeah. Simple ones. And
Okay, quick. 3,
yeah,
2,
B and B on my A2.
both fine. Nice. Okay. Yeah, no problem. Bye. Okay, let's go ahead and talk about these problems. If you think you've got the right answer, you're going to stand up. And then we are going to talk about evidence. So if you stand up for something and you don't have evidence for it, you may want to sit back down. Because if it's just a guess, then that's not what we do in math. Hey, just Sarah, can you do me a huge favor before you leave? Can you pack up Dominic? He's number 11 and get his stuff down to the nurse. Thank you, honey. Okay, if you've got evidence as to why A is correct, please stand up. Okay, so can we all agree that A is not correct?
Yes.
Okay. Can anybody tell me why A is not correct? Joyce, what do you got?
Because if you count all the bars, I guess, you get over 9.
So if you count, so this is the length down here, meaning this is 13 feet, this is 13.5 feet, and this is what we call the frequency or the number of sharks. You're saying if you start counting, okay, that's 1 shark, 2 sharks, you're gonna get over 9?
Yeah.
10 sharks? Okay, would you guys all agree Joyce is correct?
Yes.
Okay, so next one, stand up if you think B is the correct answer. If you got evidence, keep standing. Okay, Michelina, talk to us about why there are 50 sharks total measured.
So I kind of did it the harder way almost, but it was just easiest for me. So I just counted them all up.
Okay,
That's pretty much all I did.
help me do that.
So the first 2 you can see there's like only 1.
Okay,
Like 1. And then the next one is 4.
okay,
And the next one is 10.
okay. Keep going.
And the next one is 10 also.
Okay,
And then the next one is 9.
okay,
And then another 10. And you
okay,
go back down, it's 4 again.
okay.
And then you go back down again, and it's another 1. So you add all those up, and then you got your answer.
And then you end up with 50. If you agree with Michelina, could you show her? So here's where my class got kind of stuck on this one, Michelina, and you guys didn't as much get stuck on this. A lot of my kids thought this right here, the y-axis, was the length. They accidentally thought, oh, well, the length is 10 or the length is 8. Instead of knowing that the y-axis is always going to be what, everybody? The number. And the fancy math word for number is? Frequency. Okay? So the y-axis is not labeled, but we need to infer or just educated guess that it does mean the number of the sharks. Okay? So when you count them all up like Michelina did, you see B is the correct answer. The next one, the longest shark that was measured was 10 feet long. Could you please stand up if you have evidence for that one? Nobody. Okay, can anybody say evidence why it is not correct? Sounds like we all agree it's not correct. Yeah, what you got?
The boxes aren't the number of sharks. It's the bottom though. It's like the y-axis. That is.
Okay. So
And-
you're saying the bottom is the x-axis?
And that's so I said the boxes.
Uh-huh.
You know the blue boxes. That ain't the number of sharks. If you count how many there of the boxes there are, it says 9. It's 9. But but it's the number on the left on the y-axis that's the number.
So you're saying the length is down here. So if you're looking at 10 feet in length, do you guys even see 10 feet in length down here?
No.
No, that would be like what, over here?
Yeah.
Okay, so are any sharks 10 feet?
No.
No, it's not even displayed on the data. Okay, good thinking, Logan. Okay, if you have evidence that D is correct, could you please stand up? D. Okay, can anyone prove why it's not correct? Kate, what you got?
You can kind of tell by looking at it. So on the x-axis, 16 is like further than all the other numbers on the left side.
Okay.
And there's like 2 10s, 1 9, 2 1s, and 1 4.
Okay.
And you can kind of just tell that the left side is bigger than the right.
Okay, let me pause for a second. Papa. Thank you. And Raj, can you go wait at the door for Miss Christina, please? So, Kate, you were saying if you look at where the 16 feet or more, because that's what they're saying, over 16 feet, that is this, this, and this, correct?
Yeah.
Which added up is about what?
15.
About 15. So you're saying 15 is definitely not most of the sharks.
Yeah.
Because there's a total of how many sharks, everybody?
50.
Okay, so 15 out of 50 of them are over 16 feet. Is that most of them? No. Not even half. Thank you, Alex. Okay, so that one's not correct. Stand up if you have evidence as to why E is correct. Bradley, you want to share? Okay, go for it.
Okay, so it says that so there's 2 sharks less than 14 feet because if you look at the 14, it has to be 13 because you do less because if you do 14, it'll be over, and you count it and it's 2.
Okay, so 2 of the sharks. Can you go point to where those 2 sharks on the histogram are going to be? Ah, right there. And those are going to be the less than 14. Okay? Questions for Bradley as to why that is correct? Miss Christina, would you mind? Could you sit with Orange Team today? Thanks. Okay, so B and E. That's it. Pretty simple. Makes sense? Okay, so one of the things I want you to really remember today as we're looking at histograms is your frequency or your numbers. They're going to be right here. And then you need to read the x-axis and see what it is. Okay, that's kind of the point of lesson 5. All right, and who was gone yesterday? It was Tanner and Anna. Anna, Tanner, was that making sense to you? Yes? Yes? Okay, super. All right, can you look at 7.1 on the next page, page 54 for me, please? Would you be so kind to read through 7.1 on your own? I'm going to give you, bless you. I'm going to give you 1 minute to do so. 1 minute for 7.1. Sorry, I keep forgetting to move next second. We're getting video recorded today, so sorry, I forgot to tell you. Why don't you talk about the answer with your neighbor?
I said C. Because like B. I don't know. Because I feel like it doesn't really there's only population at what age you can
I said
vote.
B because
to do with the
for A.
Are we on the next slide?
Only one person at your team has actually made a selection, so why don't you talk to your team? You two have different answers. You guys do.
What about the population? It just tells me a number of 8. I also kind of think that Alaska doesn't mean either or number 8. Is this not a good thing?
I feel like it's B because it's A, C, and D, so like you could probably answer them
But like,
with the histogram. B,
choose Alaska's
That shows you the number
yeah,
what age?
And does it sound statistical? What makes something statistical? Variability, having different answers, lots of different people. So you're saying that's going to give you only one answer? So is there one of them that would only give you one answer? Which one? Does that change your answer? Yes. Okay. Thanks. Nice job, Hunter. If you can hear my voice, clap once. If you can hear my voice, clap twice. Hey, that was pretty good. All right, Joyce, give us one more activity minute. Would you raise your hand if you think A doesn't belong? B doesn't belong? C doesn't belong? And D doesn't belong. Okay, so we're kind of in between C and B right now. Pink team, number 1. What did you think?
I couldn't really go to. I was able to go up.
Okay, where did you get stuck?
I was debating which question I should use.
Okay, so the class decided it's probably B or C. I'm going to come back to you, Jonathan. I'd like you to decide for yourself which one you think it is, B or C. Okay? It could be A or D, but the class is thinking B or C right now. Blue, number 1. Brooklyn, what does your group think? B doesn't work. Why do you guys say B? Sorry, I can't hear you, honey. B doesn't make sense with any other of them, okay? What do you mean when you say it doesn't make sense with any of them? It's not a statistical question. How many of you also saw that Brooklyn saw B is not a statistical question? Okay, statistical questions have a couple of things. They have variability, which means lots of variety in answers, and how many people does it survey? A lot. Okay. So if we look at question B, if we asked a lot of people or if we asked one person, what would the answer be? Would it be the same every time or would it be different? Same. What age can Alaskans vote? Is it going to be the same answer or different? Same. If they're educated, yeah, it's going to be the same. If they don't know, then maybe they'll give an incorrect answer. But the voting age in the United States, which Alaska is a part of, is 18. 21 is different. So yeah, I would agree with Brooklyn. Jonathan, did you have any feedback on that?
Yeah, I would agree with
Why do you agree with Brooklyn?
It's actually like the population of Alaska. That's just telling what age of Alaska.
Okay, so this is going to have one answer. I write this down. So it's not statistical. And the rest of them happen to be statistical questions, okay? So nice job, Brooklyn and team. I know, Hunter, you were a big part of that discussion. Thanks for figuring that out. Joyce, when you have a minute, we're going to give 5 to blue and 3 to pink. Okay, moving right along. This next portion, 7.2, it asks us to do some measuring, and my class, goodness, I noticed it took us way too long to do this simple task, and so if you don't have a ruler and or if this part makes your head hurt, please do not stress out about this. The point of this next part is that there was some data collected about earthworms. Could I have someone read 7.2 out loud really quick? Manuel, go for it.
An earthworm farmer set up several containers of a certain species of earthworms so that he could learn about their lengths. The lengths of the earthworms provide information about their ages. The farmer measured the lengths of 25 earthworms in one container. Each length was measured in millimeters. Using a ruler, draw a line segment for each length.
Okay. So the point of this is for you to understand how long these earthworms were, not to see if you can remember how to measure, which I found in my class was scary. How many people were like, I think I'm done. I'm like, you just drew 20 inches. That's not even close to 20 millimeters. Good Lord. Okay, so if you have a ruler, great. Seems like maybe half of you do. Something you need to remember about rulers is there's often a centimeter side and an inch side. You guys know that, right? Okay. Now my ruler is kind of hard to see because it's a darker color. Does anybody have a lighter ruler that I can swap with? You do? That may work. That ruler is really old. Okay, so if you're looking at your ruler, oh perfect, thanks Joyce. See how this inch side is quite a bit bigger than the centimeter side?
Yes.
Okay, that is like old school. You should have known this for a long time. But just in case you needed a reminder, we're going to use the centimeter and millimeter side today. Okay, so I want you to find 1 millimeter, or excuse me, 1 centimeter on your ruler and then give me a thumbs up. Okay, what do you know about millimeters compared to centimeters? How many of those? Yeah, they're smaller. How many millimeters fit in 1 centimeter?
10.
Ah, good job remembering. So if I'm going to draw 20 millimeters, how many centimeters will I draw? 2. So if you have a ruler, draw yourself 20 millimeters or 2 centimeters. If you don't have a ruler, not a big deal. You can draw an approximate length. Go ahead and draw an approximate length. Looking at mine. Doesn't have to be perfect. Give you about 10 seconds to do this. Okay, moving on. Go ahead and draw 40 millimeters next, which happens to be equivalent to what?
4 centimeters.
4 centimeters. Okay, you guys are way sharper than my class was on their measuring. Take about 10 seconds to do that. And moving to 60 millimeters. How many centimeters is that?
6 centimeters.
About 10 seconds to do that. If you don't have a ruler, you're trying to eyeball it. And go ahead and do 80 and 100. Thumbs up when yours looks about like mine. That was very nice of you. I'm not as nice. I'd be like, just eyeball it. About 10 more seconds. Okay, everyone say earthworm.
Earthworm.
Everyone say data.
Data.
Can you look at the top of page 55 for me? You'll see a bunch of earthworm data. And that data was collected by somebody, a scientist, mathematician, and they were trying to figure out what is a typical length of an earthworm. Okay, and so to do that, they got about 25 earthworms. And here's kind of a, just, I guess maybe a little bit of help to see how long 20 would be. So most of the time when I see earthworms, I don't know, they're probably like that big. I would say maybe 60. Is that kind of what you guys normally see?
Yeah.
Okay, so as we're looking at the data, we might see some that are typical, maybe like a 60, but we might also see some that are small because I know they break off. I actually did a project in 5th grade all about earthworms, and if you break off an earthworm, it can then be 2 earthworms, which I thought was pretty sure I remember. It's super weird. But anyway, so it's possible to have a very tiny earthworm, but here's all the data. And these are the lengths of the earthworms in which unit of measurement? Millimeters. Okay, so we know how to do this. We've done this with frequency tables. We're basically going to track how many of them are between 0 and less than 20. Less than 20 means 0 through which number? 19. So would I include 20 in this one?
No.
No, 20 would go where? To the next one. Okay, go ahead and join me. Here's 6. That's going to be between 0 and 19. I'm just going to put a tally mark for now. You could go through and count if you want to. 11 goes here. 18 goes here. 19 goes here. 20 goes there. Go ahead and finish up your frequency table without me. Do you understand how to put those into here? Okay, so this is all of them between 0 and less than 20, so essentially 19. Okay, so 6 goes where? Yep, you got it. Keep going. So there should be only 4 in this first box. This is less than this is 19 and less, 19 and less, 19 and less, 19 and less. So see how that's 4? Okay. What about 20? Where is that going to go? Yep. So do a tally. What about 23? So this is all of them between 20 and less than 40, which essentially is going to be 39. You bet. Keep going. Tanner's just about done. Manuel's halfway there. Looks like Osvaldo's done. So is Bradley. Robert's done. So is Hunter. Do you understand how to count these? So these are all of them from 0 to less than 20, which essentially means 0 through 19. So 1, 2, 3. And these are 20 through less than 40, so it's 39. About 3. Not done. Casey. 2. 1. Okay, would you mind reading me your frequencies? Ready? Begin. 4,
12, 6, 2, 1.
Nice, you guys did them perfect. Okay, so let's go ahead and change that frequency table to a histogram, which we did yesterday. We did on our exit ticket yesterday. I think you guys did it this morning, maybe if you had time. Okay, so taking this table, here's what you need to know. This is the frequency. Where did we talk about the frequency is going to go, on the x-axis or the y?
The Y.
Let's go back to our homework. Where was the frequency?
The Y.
The y-axis. Very good. So let's label that frequency. Another word for frequency is what?
The
Number of whatever we're counting. And what are we counting this time?
worms.
Yeah, number of worms. Okay, so that's the y-axis. And then what's going to be the x-axis this time? What's the x-axis going to be?
Length.
Worms.
Okay, we got the number of worms.
The length.
The length in millimeters. You got it. Nice job. Write that down. So far, so good. Minraj, you got the x and y axis labeled? Okay. Kimberly, you got it? Okay, super. Okay, now I'll do the first one. But one of the errors I noticed in my class was that some kids were just doing like 0 to 10 and calling that one bar of their histogram. Okay. He is, I believe, still SBA testing in Miss McCann's room. And if he's not in Miss McCann's room, he's in Dyer's room. Yes. Okay, so some kids were doing 0 to 10. Why is 0 to 10 not going to be my first bar? What does it say up here?
It's 0 to 20.
0 to 20, technically 0 to 19. So I want your first line to go from 0 to 19/20. It doesn't include 20, even though it kind of looks like it does. Okay, how high will I go up on the frequency?
4.
Okay, go ahead and draw that. Shade in or not, I don't care. And once you have what I have, you can finish the rest of your histogram on your own. I will do the same. Give you about a minute. So this should be your second one right here. Because 20 to 40 was 12. So you see that? Okay, next one's gonna be 6, perfect. Here. Oh, are you gonna draw the boxes later? Oh, I understand what you're doing. Looking good over here. Tanner, you were doing the same thing that I was just saying in my costume. So see how the data needs to go from 0 to 20? Exactly. Yep, you nailed it. Nice job. Are you stuck on the next step? Okay. So see how the frequency is 12? See how it goes from 20 to 40?
Yeah.
Okay, here's 20, here's 40, and we're going to go up to 12 because the frequency is 12. Okay. Does that make sense? So now go 40 to 60, and how high are you going to go up? You got it. Okay, histogram's looking really good. So see how it goes from 20 to 40? Okay, so you're going to go 20 to 40, and then up to what number?
12.
Yep, 20 to 40, up to 12. There's your box. You see it? Do you understand now? Okay, cool. I'll show you mine. If it looks different than mine, you can do a quick fix. Feel free to ask me questions if you don't know how I came up with my numbers. The common error that I saw as I walked around, there was about 4 of you who did this, was you weren't sure what to do with the bottom part. So you got to look at what the data range is, kind of like what Joyce was saying this morning. Start from 0 and go to 20. 0 to 20. Then it was 20 to 40. Then it was 40 to 60. So that's how you make your box. Does that part make sense now? Okay, cool. Now we get to reflect a little bit about our histogram and talk about our histograms. Okay, that was part of our learning target today. So it says, based on the histogram, what's going to be a typical length? I want you to think about that for a second. Don't say anything. What would be a typical length of one of these earthworms? Typical length. Look at your histogram. Tell your neighbor, what do you think?
20 to 40. 20 to 40.
Yeah, 20 to 40.
Yeah.
Wait, how many? There's 25 and then that's like actually
Cameron, look and talking. Turn towards him.
like 12.
I would think like 20 to 30.
And you gotta figure out.
Oh yeah.
39 and how to draw this.
Like 50%.
3,
Like 49%.
2, 1. If you can hear my voice, clap once. Oh, good. Red team, number 1. What do you think would be a typical length? Is that Manraj? 20 to 40. Why do you think that? That was a good guess. Talk to me about where your brain was at with that. Yeah, it's definitely the highest. How many of you had something like 20 to 40? Okay, anybody have something else? You want to say something to Manraj? We calling somebody Manraj?
Oh yeah, I mean 20 to 30.
Why is that 39 Manraj and not 40?
Because 48 started a different category.
Right, starting the next bar there, next bin. Cool. Everybody in agreement around 20 to 39 because it's the highest, write this down, frequency. Okay, it has the highest frequency, so that is a great guess for a typical length of an earthworm. Bless you, Hunter. Questions for Manraj? Okay, Joyce, can you give him 5 points for his team? Okay, we're gonna pass number 4 and the Are You Ready for More and go straight to 7.3. 7.3 asks you to really look critically at a histogram. And when I first looked at these 2 histograms last week when I was planning this lesson, I didn't see something until later. Like it took me a couple minutes to see something. So here's what I want you to do. I want you to read through 7.3 and I want you to try to answer number 1 by yourself. I'm going to give you 1 minute to think about it and read. Go ahead. heads together, brainstorm together.
Okay. A is baseball and B is basketball.
I said
A is
I read that wrong. It said it was both basketball.
It was like what?
This is cited to this is
Because basketball is
Yeah, I think
top.
A was basketball.
A is basketball.
Did you read number 1 correctly?
What do you think?
After it said
Yeah.
that, it was bigger because it has
It said the side of each histogram shows the height of baseball players.
higher
Right shows the height of basketball.
everyone's taller. Yeah, 72. But it's not.
Highest.
Height is the majority of basketball players are taller than baseball players. So
Baseball player.
If you can hear my voice, clap once. If you can hear my voice, clap twice. I heard both ways that I was thinking. I heard the first way that I was thinking when I thought about it incorrectly. And then I heard several of you do what I did, and then I looked at it and I went, oh, I see it now. So I'm curious what we're going to get. Let's hear from Purple 3. A or B, and why? Is that Brayden? Yeah. Oh, Brayden. Okay, great. Okay, which one did you happen to pick? B? So it's just a guess. Okay, how many of you also chose B? Okay, can anybody articulate why B was correct? Brayden, want to call on somebody?
Okay, so if you look at it, it said, or if you read it, obviously, it said that basketball players tend to be taller than baseball players.
Sure.
So the highest height was, for B was 80 inches, and the highest for A was 90. So you can kind of see that B is shorter than A.
So you're saying the shorter players are on B?
Yeah.
So are you agreeing with Brayden or disagreeing?
Yeah, I'm agreeing.
So you're saying the shorter players, are you thinking baseball is
Yeah.
the shorter players? So he's saying, question's saying,
Sorry, I read it wrong.
you read it backwards, didn't you? So they're looking for us to circle the basketball player one. So you had your thinking, you just swapped the graphs. Or you didn't swap the graphs, you swapped what the question was saying. So you're saying this is the basketball team and this is the baseball team.
Yeah.
Okay, Brayden's saying the opposite.
Okay, well, yeah, then I am.
So you're disagreeing with. Okay, does anybody agree with Brayden? Did you have your point sheet today? Okay, why not? Did you ask her? Who prints you papers? Miss Winley? Okay, ask her for me, please. Okay. Anybody agreeing with Brayden? Because he's not sure why he chose that one. It was just a guess at this point. Okay, rats. Well, I guess we got to go to the other one then. How many of you chose? Actually, let's just go back to my little sticks here. I was hoping to give purple some points. Right now, I got to give blue 3, though. Joyce, can you give blue 3? Let's hear from orange team number 3. Oh, that's Elizabeth. Okay, fill in.
I'll do it.
Okay.
So, originally, I picked B, but then Kate was talking about it, and then picked A.
So her thinking kind of swayed your vote there. Can you restate for maybe Brayden and other people who are still unsure about how to read these histograms? Why is this one the basketball one?
Because if you look at the x-axis, it shows the inches of the players.
Okay.
It goes from 90, and it goes from 66 to 90, and the majority of them are between 73 and 80 inches.
Okay.
And if you look at the x-axis on the baseball players, the majority of them are between 67 and 75.
Okay?
So, and the story said that basketball players tend to be taller than baseball players. So, A is correct.
Okay? I'm agreeing with a lot of your thinking. The only thing I wanted to touch on is this data is going to start at 70. See how it's starting at 70? And it's going to end all the way at 90. I'm not sure if I heard you say that explicitly, but I just wanted to clarify that. Do you guys see how it starts at 70 and ends at 90? Yeah. Okay, so that's the height of these players. So if someone's 90 inches, is that way taller than 80 inches? Yes. Yeah, for sure. So these are the shorter players. It goes from 66 inches to 80 inches, actually 79, we're going to be accurate. Okay, so we've got the range of 70 to 90 compared to 66 to 79 inches. So obviously this is the shorter team, therefore it has to be what? A. Has to be baseball, yeah, so it has to be A. Okay, Brayden, does that make sense? Okay, so here's where I got stuck up, and I bet Emmanuel and Brayden were thinking the same thing. I looked at this really tall graph, and I went, oh, this is basketball, they're tall. Did anybody else think that right off the bat? Yeah, me too. But then I started thinking about it. Kimberly, can you run and tell Mrs. Dyer we're going to need like an extra 3 minutes? Then I started looking at it and I went, oh, well, this is showing the heights down here, not the frequency. The frequency is the number of basketball players. So here's how we'll wrap up class today. There's some really good stuff on the summary to help you kind of organize your thinking. In about 3 minutes, maybe 2, I'm going to put up the exit ticket. But in the meantime, I'm going to give you some time with the summary. You can use that time for your journal, reading over the summary, however you see fit. As soon as you have your Think About It pad, you may put your name at the bottom. Lesson 7 at the top. And you'll need the data on the screen in order to complete your exit ticket. So this is your ticket out the door today. Nice job, mathematicians, and I will see you tomorrow. I will send Mrs. Dyer your homework right now. Feel free to come up if you can't see the board very well.